Now, what about a person who is skydiving who would receive reasonable amount of air resistance while accelerating downwards? What would an actual observed acceleration be at any given moment? Well, let's take a look at the skydiver here. Of course, force gravity straight down. An upward force this time of air resistance. Let's put some values in for the skydiver. Let's say he is 65 kilograms in mass, and he has an air resistance force acting on him at this instant of 40 newtons. In this case, we see the forces are not balanced, and we would have an air resistance force acting on him. Force net would equal force of air minus force of gravity. Let's solve for force of gravity. We'll take 65 multiplied by 9.8. This will be 637 newtons. Let's substitute into our force net equation. Force net, of course, is always mass times acceleration. So we have 65A is equal to air resistance force, in this case, is 40. And now we'll subtract the force of gravity, 637. Solving for A, we get an acceleration of negative 9.2 meters per second squared. And we see that that's pretty close to gravity acceleration, but as he continues to fall and his velocity increases, the amount of air resistance force will also increase. And at some point, he will reach what's called a terminal velocity, at which he cannot accelerate any longer. Let's take a look at that situation. So we're now at terminal velocity. We'll look at the forces again, and we'll see how things have changed. So for a terminal velocity then, force gravity straight down, force of air again opposing. For a terminal velocity, that means acceleration does equal 0. Therefore, force gravity and force of air must equal each other. We still have the same force net equation. Force net is equal to force of air minus force of gravity. We'll now substitute values in. 65 times 0 equals force of air minus 637. And we see mathematically that the force of air must equal 637 newtons.